Several viewers requested the topic of e-commerce in Volt. Today I'm going to walk you through the creation of a pre-order page like the one you see here. It's going to process payments using Stripe, which I've found to be a very good solution for most use cases. At the end of today's episode, I'm going to make a special announcement about the screencast series, so stay tuned. With that being said, let's get started. The payment form has two use cases, success and failure. Entering bad credentials results in the error message you see there. Entering good credit card information will result in a success screen. When I log into the Stripe control panel, you can see that the payment transferred. Let's see how we would do this using Volt. Before we go too far into the Volt part of it, let's talk a little bit about how Stripe works. Stripe provides a JavaScript library that grabs payment information from HTML forms and submits them directly to Stripe. Once Stripe has the customer's payment data, the API returns a one-time payment token to the browser. This payment token can be used on your server, which eliminates many of the risks of storing credit card data. All of the examples that they have on their website, though, are using the Stripe.js library. On the front end, you would traditionally use Stripe.js to create a payment token. I've created a thin wrapper for Opal users that lets you do that without needing to drop down to JavaScript. When you're ready to process customers' one-time payment tokens on the server, you can use the Stripe gem, which has been provided by the nice folks at Stripe. In our case, we're going to use it inside of a task object. Check out episode 1 if you're unfamiliar with task objects. The first thing we're going to need to do in the source code is add the two Stripe gems. Remember, Stripe Opal is handling the creation of one-time payment tokens on the front end, and then the Stripe gem is going to handle actually charging credit cards on the back end through the use of a task object. You should also be aware that I'm using Volt version 0.95 pre-4. Make sure you've got the latest version when you get started. It won't work on previous versions. We still need to add the stripe.js file for access by Stripe Opal. If you remember earlier, I said that Stripe Opal is just a wrapper around the library, so you still need to include it here. The way that you include JavaScript files in Volt is by using the syntax you see here. And then once we're done with that, we're going to go into boot.rb. And within boot.rb, we're going to conditionally require the Stripe Opal gem, because we don't want to load the Stripe Opal gem on the back end. There's no need for it. Now on to the view. Here I am in index.html. I'm going to add some base scaffolding. You'll notice I put a conditional binding in this view. If this were a larger app, it would be wise to refactor this into two separate view tags, but for the sake of simplicity, I'm just going to keep it in one file. In this use case, the page is going to have a variable called sale, and it will reactively render either a confirmation page or a payment form based on its presence. As you might remember from episode 10, the page store is used to temporarily store things in browser memory, in this case, a payment object. Next, I'm going to add an overly simplified confirmation page, and then I'm going to add a payment form that's going to get the customer's payment data and turn it into a one-time payment token. Let's talk about Stripe payment forms really quickly. Specifically, I want to talk about what's going on with the elements and attributes on the form I just pasted in. The official documentation for payment forms at Stripe do a pretty good job of explaining how to build a payment form that's compatible with the Stripe.js library. Two things to note about payment forms that use Stripe.js, though. The first thing to note is that inputs have no name attribute. You do this because you don't want any credit card data accidentally hitting your servers or ending up getting stored in logs. The other thing I'd like to point out is these data-stripe attributes. They have a fairly obvious naming convention and are used by Stripe.js to create your one-time payment token. At a minimum, you must provide a card number and an expiration date, and we did that already in the last one. There's also some others available, but we won't cover them today. Now I can add the eSubmit binding to the payment form. The eSubmit binding executes a controller method when the user clicks the Submit button or presses Enter. This is different than a normal form submission. Putting the eSubmit binding allows us to handle the form submission inside of the browser using the Stripe Opal gem. Let's go into the controller and add that Submit Payment method now. Within the controller, I need to call the Stripe Opal gem that I included earlier. The method call that you see here basically searches the DOM for the payment form and then attempts to create a Stripe payment token with the information that's provided inside that form. Since it returns a promise object, we can attach a .then and a .fail method, and that's going to handle success and failure cases. The failure case will just flash a message to the user letting them know that the payment was not successful. But what about this success case right here? I said earlier that payment tokens needed to be processed over the server, but right now we're still inside the browser. How could we avoid the security issues seen with running code inside of the browser? For instance, how would we prevent the user from modifying the sale price? This is where we're going to use a task object. This can execute code securely on the server and then report the results back to the browser. I'll make a task object that consumes a payment token and returns a response to the front end now. Now I'll type volt-g task and the name of the task, which I'm going to call this one payment task, and then Volt is going to scaffold everything out for us. Like I said earlier, if you're not familiar with tasks, check out episode 1 where I do a real deep dive into how they work and how to use them. Before writing the task code, I need to set the Stripe API secret key. Now, I'd like to point out that this is just an example, so I pasted in what a secret key would look like. In the real world, never do that. In the real world, you would want to store secrets inside of an environment variable. And the reason that you want to store things inside of environment variables is because you don't want this getting into source control and having to deal with possible unscrupulous characters getting into your Git repository and then running amok with your Stripe account. So make sure that you do it this way when you're actually writing a production app. Now that that's done, I can write a method that takes in a payment token as one of its parameters, and then using that payment token, I'm going to use the Stripe gem to actually charge the user's credit card and get paid. The Stripe gem syntax is pretty straightforward. A couple things to point out though. You'll notice that all prices are entered in cents, and that's just to avoid rounding errors. And you also need to pass in the token using the source parameter. That's all you need to do to run payments and charge a credit card. We can hop back into the controller now and start handling responses from this task object so that the user knows that their payment went through. Now let's go through and finish things up in the controller and also use that task object that we just created. The first thing we want to do is actually call the payment task like we do here. You'll notice that I'm calling the ID on the token because I just want to pass in a string. I don't want to pass in the whole object. The payment task is going to return a promise in the same way that Stripe Opal returned a promise when it was generating a one-time payment token. It's interesting because we can chain our promises this way and then share a single failure case. So once the sale object is generated, I'm going to pass it to a method called complete purchase, which I've yet to define. There we go. And complete purchase is going to take in the sale object and then attach it to the page store so that we can access it from within the view. We want to do that because later on in episode 2, or should I say part 2 of this episode, we're going to create a receipt page. Once that's done, we flash a success dialog to let the user know that it's complete and the transaction is finished. Let's go into the browser to make sure it worked okay. And here we go with some fake payment data. And it looks like everything went okay. It swapped out our template with the success message and also did the flash dialog. The Stripe side of things, it also registered our payment, so this one is successfully completed. Before finishing up, I'd like to make a special announcement, and that's that we will begin offering premium videos this month on a Name Your Price subscription basis. Proceeds from the videos will help fund future episodes and give you access to ad-free streaming content that's not available on the YouTube channel. If you're interested in signing up, check out the DataMelon blog and just click the link for premium videos. Once you get there, you'll be prompted to name a fair price, and we really do appreciate the support. So thanks for watching, and as always, if you have any questions, feel free to leave a comment. See you next week.